Okay, problem 15. The function f has a first derivative given right here. What values of x does f have a relative max? Okay, so we need some critical numbers. We see 0, we see 3, we see -1. So we're going to take those 3, which is why we see all those zeros, and we're going to put them on our number line. And we're going to do a first derivative test. So we'll pick a number to the left like -2. If we have x is -2, that is negative. -2 minus 3 is negative, but we square it, so that term is always going to be positive. -2 plus 1 is negative. A negative times a positive times a negative is a positive. All right, now we pick a number here. Let's go with -1/2. -1/2 is negative. This term is always positive. -1/2 plus 1 is a positive. So we have a negative times a positive times a positive. There's only one negative sign, so that term will be negative. Now over here, we pick a number like 1. 1 is positive. This is positive. 1 plus 1 is positive. Positive times positive times positive is positive. And then over here, we pick a number like 4. 4 is positive. That's positive. 4 plus 1 is positive. Same thing. So we're looking for a relative max. Relative max means that f prime is going to go from positive to negative. And the only time that this goes from positive to negative is at -1. So the answer is A. 16 asks, which of the following intervals is the graph f both decreasing and concave up? So we need f prime to be negative and f double prime to be positive. All right, let's start by getting our derivatives. F prime will be 6x squared minus 6x minus 12. F double prime will be 12x minus 6. Okay, so this is looking for a first derivative test and a second derivative test. We need to find the first derivative is equal to 0. Just like an earlier problem, let's factor out a 6. That leaves us with x squared minus x minus 2 is equal to 0. 6 is not 0, so we're looking when that will be 0. So we're going to split it up into a couple of binomials again. We know that the only way we can get x squared is x and x. We need two numbers that multiply to -2 and add to -1. So that's going to be -2 and +1. So our values are 2 and -1. And we're going to have to do a number line with 2 and -1 on it. All right, so we'll pick a value to the left of -1, like -2. If we plug -2 in here, -2 minus 2 is negative. -2 plus 1 is negative. Negative times a negative is a positive. Pick a number between -1 and 2, like 0. Right, that was -2. If we plug in 0 here, again, I could have plugged 0 in any part. I'm plugging into this version right down here. 0 minus 2 is negative. 0 plus 1 is positive. Negative times a positive is a negative. And then we plug in a number greater than 2, like 3. 3 minus 2 is positive. 3 plus 1 is positive. That will be positive. Okay, so we're interested in f prime decreasing. That's f prime, I'm sorry, f decreasing, so f prime is negative. So right now our interval is -1 to 2. All right, but we also need to check out f double prime. We need f double prime to be positive. Here's f double prime, set it equal to 0. 12x is equal to 6. X is equal to 1/2. So now we're going to do a concavity test. There's 1/2. We plug in a number less than a half, like 0. 12 times 0 minus 6 is negative. Plug in a number bigger than a half, like 1. 12 times 1 minus 6 is positive. We want when f double prime is positive, so that is when x is greater than a half. So we merge these two. We need greater than a half, but between -1 and 2, so we got to stop at 2. We got to start at a half. So we have 1/2 to 2. The answer is D. All right, 17. These points are on the graph of the function, -1, -1, and 1, -5. And here's our diffie-q. Which of the following must be true? We're being asked about these points being a local max or a point of inflection or a local min. Okay, so this is looking like a second derivative test here. Let's plug these numbers in. If we plug the numbers into the first derivative. Negative 1, negative 1. Negative 1 squared is 1, plus negative 1 is equal to 0. So for this case right here, dy dx is equal to 0. All right, so then we plug this value in and we see 1, negative 5. Well, that's going to be 1 minus 5, which is negative 4. That's definitely not 0. So dy dx does not equal 0. All right, we know that for our second derivative test, we're looking for the derivative equal to 0. So let's check this point out. What do we need to do? Well, first of all, we need the second derivative. If we're going to do the second derivative test, we need the second derivative. So d2, damn it, let's try that again. d2y dx2 is going to be the derivative of x squared is 2x. The derivative of y is dy dx. And dy dx is x squared plus y, so we end up having 2x plus x squared plus y. That's the second derivative. Let's plug in our values. So we plug in negative 1 for x. We plug in negative 1 for y. We have negative 1 times 2, so that's negative 2, plus 1, minus 1, that's negative 2. So the second derivative is negative. Means our function is concave down. And we know that the first derivative is equal to 0. So we have a horizontal tangent line. So that point right there is a relative max. The answer is C.